Imagine you're driving this massive million-pound freight train.
Okay, I'm picturing it.
Right, and it represents your company's legacy SAP system. I mean, it never derails. It carries the absolute lifeblood of the company's operational data, but it takes like 3 miles to come to a complete stop.
Yeah, it operates on its own set of rules, basically, its own physics.
Exactly. Now, your CEO walks in and says they want you to run a high-speed bullet train on the exact same track,
Oh, wow.
simultaneously, without crashing either one.
That sounds terrifying.
Right. You have to match the velocity of modern software development, but you also have to maintain the ironclad reliability of a system that runs your entire global supply chain.
Which is no small feat.
No, it's not.
Yeah.
And today, we are getting into how SAP is using DevOps, cloud integration, and Git to pull off that exact architectural miracle.
It really is a delicate balancing act. And, it requires a complete paradigm shift for anyone who's spent their career managing traditional SAP landscapes.
Yeah, for sure.
We are looking at bridging the gap between classic SAP-specific environments, which, let's be honest, have relied on highly specialized, frankly, isolated logic for decades, and the modern, agile CI/CD world.
Right, continuous integration and continuous delivery.
Exactly. The CI/CD pipelines that the rest of the software engineering industry has been using for years they're finally coming to the SAP core.
And that is why this particular deep dive is going to be incredibly intensive. So if you are an SAP architect, a basis administrator, or a developer trying to navigate this transition, I want you to consider this your masterclass.
We're definitely not skimming the surface today.
No way. We are skipping the high-level executive summaries today. There's going to be no abstract theories about, agile synergy.
Thank goodness.
Yeah, we are getting straight into the architectural blueprints, the pipeline configurations, and we are going to completely demystify the Git-enabled change and transport system.
Also known as gCTS.
Yes, gCTS. So as you are listening, I want you to start mentally mapping out these configurations in your head, because you can actually apply this to your landscape tomorrow.
That's the goal. Actionable steps.
Exactly. But let's start with the foundational philosophy SAP is pushing here. Specifically, their reliance on the SAP Business Technology Platform, or BTP. Because before we configure a single pipeline, we really have to understand the why.
Yeah, and the why is actually formalized in SAP's own mission statement regarding DevOps. They aren't just selling a tool here.
Right.
They are positioning themselves as a trusted advisor to help customers apply standard DevOps principles across the entire SAP technology stack.
Okay.
And they anchor this philosophy in a well-known industry standard, which is the CALM-S framework.
CALM-S. Walk us through what that stands for.
Sure, it stands for Culture, Automation, Lean, Measurement, and Sharing.
Okay, I mean, I've seen CALMs applied in standard web development environments constantly, but applying it to a legacy ERP environment, that is a completely different beast.
It's a huge shift, yeah.
My immediate thought, and honestly, the thought of any SAP veteran listening right now, is going to be about risk.
Naturally.
Like, if I embrace this DevOps culture, am I being asked to rip out the operational framework I've spent 20 years building?
That's the big fear.
Yeah.
Yeah.
Do we have to throw away tools like SAP Solution Manager or SAP Focused Run just to chase this new agile dream?
It is a very valid fear, but the answer is a definitive no.
Oh, okay. That's a relief.
Yeah, SAP's strategy explicitly respects your existing operations. The goal here is not a rip and replace of your mature IT service management.
Right, because enterprises have millions of dollars invested in SAP Cloud ALM, Focused Run, and Solution Manager.
Exactly. The objective is to extend those existing trusted processes so they can seamlessly govern cloud changes right alongside your traditional on-premise or private cloud changes.
So it's an evolution, not a demolition.
I love that phrasing, yes.
Evolution.
I want to ground this in the real world for a second, using a business scenario from our source material that I think perfectly illustrates this tension. Ah, yes, the famous rotating banana scenario.
Yes. The sources use a hypothetical company, and it really does have a fantastic name, Rotating Banana.
It definitely sticks in the mind.
It really does. So Rotating Banana is your quintessential long-time SAP customer. They have this massive on-premise SAP footprint. And they know they need to start their cloud transformation, but their IT department isn't filled with, Silicon Valley cloud-native DevOps engineers.
Right, they have traditional SAP administrators.
Exactly. So they're looking for a way to dip their toes into DevOps with a low barrier to entry. But their CIO has issued a very strict mandate. As they migrate to SAP S/4HANA, they absolutely must maintain a clean core.
And that, right there, the clean core concept, is the absolute linchpin of modern SAP strategy.
Yeah, let's unpack what that actually means because it explains why Rotating Banana has to completely change their approach.
Right. Historically, when a company needed their SAP system to do something unique, say a highly specific invoicing process for a regional market, they wrote custom code.
Using SAP's proprietary language, ABAP.
Exactly, ABAP.
Yeah.
And they wrote that code directly inside the core SAP system.
They just jammed it right in there. They modified the actual standard SAP source code or injected heavy custom developments that were tightly coupled to it.
Which was standard practice for decades.
It was, but I know from experience that creates a ticking time bomb. Because when the weekend comes for a system upgrade, all that custom code breaks.
Oh, yeah. Every single time.
It creates massive technical debt. You end up on these 72-hour conference calls where developers are frantically trying to figure out why the new SAP update broke the custom invoicing logic.
Precisely. The core is quote-unquote dirty.
Right.
So the modern approach, the clean core, dictates that you just stop modifying the standard code entirely.
Okay, so how do you get your custom features then?
Instead of modifying the core, you build those bespoke business processes as side-by-side extensions.
Ah, side by side.
Right. They run externally, and they communicate with the core SAP system via standard APIs. That way, when SAP updates the core S/4HANA system, your custom extensions remain totally untouched and fully functional.
That makes so much sense. And where do those side-by-side extensions physically live? I assume that is where SAP BTP comes in?
Exactly. Rotating Banana needs to build these external applications on BTP.
Okay, and they want to use modern CI/CD pipelines to do it, but as we established earlier, they don't have a server farm dedicated to Jenkins.
No.
They don't have a team of site reliability engineers sitting around waiting for work.
Which is the exact problem SAP BTP solves for them. BTP offers what is essentially a pipeline-as-a-service model right out of the box.
Pipeline as a service. I like that.
Yeah, you don't need to procure servers, you don't need to install open-source automation servers, configure worker nodes, or worry about patching your CI/CD infrastructure.
So it's fully managed.
Fully managed. It is a highly integrated, highly opinionated approach based strictly on SAP's own internal best practices.
So if you are an IT director listening to this right now and you're in Rotating Banana shoes, this is a massive shortcut.
Oh, absolutely.
You don't need to spend 6 months and $500,000 standing up DevOps infrastructure. You just leverage the platform you are already building the extensions on.
Exactly. You just turn it on.
But to do that, you need a structured environment. What does the actual architectural landscape look like inside BTP to support this? Because you can't just have everyone coding in one giant sandbox.
Right, you definitely can't. SAP recommends a rigid, standard 3-tier landscape, which honestly will feel very comforting to those traditional SAP admins.
Okay, walk us through the tiers.
You establish distinct, segregated BTP subaccounts. Your first subaccount is strictly for DEV, your development environment.
Okay, DEV.
That is where the engineering team deploys their daily builds. Then you have a completely separate subaccount for test.
Got it.
This is a representative environment where automated integration and acceptance tests run. And finally, you have the third subaccount, PRD, which is the production environment where end users actually consume the application.
So DV, test, PRD. That segregation is key because it prevents a developer from accidentally pushing untested code directly into the live environment.
Exactly. It creates safe boundaries.
So we have our 3 subaccounts mapped out. The infrastructure is there. But how does the code actually travel between them? Let's trace the physical journey of a piece of code from a developer's brain into that test environment.
Okay, that brings us to the SAP Continuous Integration and Delivery Service. This is a cloud service you subscribe to directly within your BTP cockpit.
Okay, so I go into BTP, click subscribe. What then?
The defining characteristics here are simplicity and flexibility. You are not forced to write complex YAML pipeline scripts from scratch.
Oh, that's a relief. YAML can be a nightmare.
It really can. You don't have to figure out the specific build commands for, say, an SAP UI5 application versus a Java microservice. SAP provides ready-made, pre-configured pipeline templates tailored for their specific runtimes.
Okay, let's walk through the mechanics of that flow. The developer finishes their code. They are likely using SAP Business Application Studio, right?
Yes, BAS, which is a modern browser-based integrated development environment.
Right. It looks and feels very much like VS Code, but it's tailored for SAP.
Exactly. So they finish coding in BAS, they hit commit, and they push their changes to a Git repository, like GitHub or Bitbucket.
Okay, so the code is in GitHub. What happens next?
That push is the catalyst. When the code arrives in the Git repository, it triggers a webhook.
A webhook.
Yeah, a webhook is essentially an automated HTTP message sent from Git to the SAP CI/CD service, basically saying, hey, new code just arrived, do your job.
I love that. So Git taps BTP on the shoulder.
Exactly. The SAP CI/CD service instantly spins up a temporary pipeline execution. It clones the new code, runs the build process, and executes the automated unit tests.
All automatically.
All automatically. Within minutes, the developer gets a green check mark or a red X. It's an automated feedback loop that requires zero manual intervention from an infrastructure team.
But wait, I have to play devil's advocate here for a second.
Go for it.
Rotating Banana loves this because they are starting from scratch. But what if a company listening to this isn't starting from scratch?
That's a very common scenario.
Right. What if they are a massive enterprise that has been doing DevOps for their non-SAP applications for like a decade? They already have a colossal, highly customized Jenkins setup. They have security scanning, code quality checks, and complex approval gates already built into their existing Jenkins infrastructure. Are they forced to abandon all of that and use the SAP managed service just for their BTP apps? Because that seems incredibly inefficient.
It would be wildly inefficient, and SAP recognizes that reality. They do not force you into a walled garden here.
Okay, good.
If you have a mature legacy CI/CD infrastructure, SAP provides a profoundly useful alternative, and it's called Project Piper.
Project Piper. It's an interesting name. It sounds like something out of a Silicon Valley startup incubator.
It does. It's an open source, community-supported initiative, and I have to say, it is a game changer for large enterprises.
How does it work?
Project Piper provides a shared library of pre-configured Jenkins pipeline steps that are specifically designed to handle the nuances of the SAP ecosystem.
Oh, wow. So it speaks SAP.
Exactly. It understands how to build a multi-target application. It understands how to interact with SAP's transport systems. You simply take these open source pipeline steps and inject them directly into your bespoke Jenkins setup.
Okay, that is a critical decision point for anyone architecting this transition right now. You have to honestly evaluate your organization's current maturity.
Yes, don't just follow the shiny new thing.
Right. If you are launching a greenfield cloud transformation and you want immediate results with zero infrastructure overhead, you activate the SAP CI/CD service on BTP. But if you have a team of Jenkins experts and a massive sunk cost in existing infrastructure, you go to GitHub, pull down Project Piper, and augment your current pipelines. It's about meeting the organization where it currently stands.
Exactly. It removes the friction of adopting SAP Cloud development by integrating into the tools your developers already know and trust.
All right, so our pipeline has successfully run. Whether we use the managed service or Project Piper, the code was built, the tests passed, and we now have a verified software artifact sitting in our test subaccount.
Success.
The QA team signs off. Now comes the terrifying part, right? Moving it to production. We need to physically transport this artifact into the PROD subaccount.
And you can't just drag and drop it.
No, because we operate in a highly regulated enterprise. We need audit trails. We need separation of duties. We can't just have a developer manually uploading a file into PRD on a Friday afternoon.
Absolutely not. And this is where we hit a significant architectural fork in the road. It is a topic where a lot of teams make a major misstep if they rely on outdated knowledge. You essentially have two options for transport management in this landscape.
What are they?
You have the modern SAP Cloud Transport Management service, or you have the legacy system, which is known as CTS plus P.
And the source material we are deep diving into is not subtle about this. They have a very strong, highly opinionated recommendation here. They say you must use SAP Cloud Transport Management.
They're very firm on that.
Let's explore why. Why is CTS Plus falling out of favor so quickly?
Well, to understand the shift, you have to understand the changing nature of what we're actually building today. CTS Plus was designed in an era where cloud development was relatively homogeneous.
Okay.
It is deeply tied to ABAP on-premise servers running as the transport domain controller. But more importantly, CTS Plus is primarily built to handle one very specific type of cloud artifact.
Which is?
The MTA, or Multi-Target Application Archive.
Okay, let me try to visualize that for the listener. Think of an MTA as a highly specialized shipping container.
Good analogy.
It's a great container. It perfectly holds different interconnected software modules like a database schema, a Java backend, and a UI frontend all bundled together.
Right.
So CTS Plus is like a specialized courier company that only owns trucks designed for that exact MTA container. If you hand them an MTA, they know exactly what to do with it.
Exactly. But the BTP landscape has evolved way past just MTAs.
Right. Today, an application isn't just an MTA. Your solution might include a custom portal site built in SAP Build Work Zone.
Yes?
It might include complex API routing logic built in the SAP Integration Suite, or dashboards built in SAP Analytics Cloud. None of those are packaged as MTAs.
Yeah. So if you hand that portal site or that analytics dashboard to the CTS Plus courier,
They just stare at you. Their truck doesn't fit the cargo.
precisely, they can't move it. And this is the stark warning from the sources. SAP has explicitly stated they have absolutely no plans to expand the content coverage of CTS Plus beyond that legacy MTA format.
Wow. So it's a dead end.
It is. Furthermore, CTS Plus lacks the API hooks to integrate into modern deployment management orchestration. It is, for all intents and purposes, obsolete for modern non-MTA cloud artifacts.
Enter SAP Cloud Transport Management. If CTS Plus is the specialized courier, Cloud Transport Management is the universal global freight forwarder.
I like that, yes.
It has the logistics network to handle everything. It natively understands the MTA, sure, but it also natively understands the work zone sites, the integration suite flows, the API management policies, all of it.
And it is entirely cloud native. It doesn't require an on-premise API system to act as a controller sitting there taking up resources.
Right.
And crucial for the enterprise constraints you mentioned earlier, the audit trails and separation of duties, it provides real enterprise-ready change management.
How does that look in practice?
You can define transport routes that enforce strict policies. You can configure it so that a transport request containing critical production changes absolutely requires digital sign-off from a specific QA manager before it is allowed to enter the PRD sub-account.
Okay, so the directive here for the listener is crystal clear. Unless your organization is in a highly specific legacy scenario where you are strictly locked into MTA-based content and you have a massive immovable investment in a functioning CTS Plus setup, you must default to Cloud Transport Management.
Yes.
Because if you plan on using any of the newer BTP services, CTS Plus will actively block your progress.
It really is the only path forward for a modern, heterogeneous BTP landscape.
Yeah.
You have to make the switch.
Okay, so the transport is approved. The QA manager clicked yes. The code crosses the bridge. We are live in the production sub-account.
Not the champagne.
Right. The application is running, users are logging in, business is happening. But software is fragile. The moment it goes live, you enter the operational phase, which means eventually something is going to break.
It's just a matter of time.
It always is. So how does a basis administrator who is used to looking at standard on-premise system logs actually monitor a distributed cloud application? Like if our app suddenly starts dropping database connections in the middle of the night, how do we see it? And more importantly, how do we automate the fix?
Okay, so the overarching strategy for central operations here relies on SAP Cloud ALM. That stands for Application Lifecycle Management.
Cloud ALM.
Think of Cloud ALM as a central command center. It is intended to be the single pane of glass where you monitor the health of your entire landscape, both cloud and on-premise.
Okay, but what about the massive enterprises that have heavily customized implementations of SAP-focused run? Do they have to use Cloud ALM?
No, SAP thought of that. For those specific customers, Cloud ALM is smart enough to act as a data proxy. It gathers the cloud metrics from BTP and just feeds them seamlessly into focused run. But for most standard use cases, Cloud ALM is the orchestrator.
But Cloud ALM needs eyes and ears, right? It needs the raw data to make decisions.
It does.
That brings us to observability. And the specific tool here is SAP Cloud Logging. And I really want to pause and appreciate the technical underpinnings here because it represents a huge shift in SAP's approach.
It really does.
SAP Cloud Logging isn't some closed proprietary black box that only SAP understands. It is built directly on top of OpenSearch.
Which is incredibly significant. OpenSearch is a highly respected, heavily utilized open source search and analytics suite.
It's a fork of Elasticsearch, right?
Exactly. By adopting OpenSearch, SAP is giving developers a tool they likely already know how to use. There's no massive learning curve for the observability layer.
And what OpenSearch does brilliantly is index massive volumes of unstructured data. In a cloud environment, you don't just have one simple log file sitting on a server.
No, it's chaotic.
You have application logs from a Cloud Foundry runtime, you have container metrics from a Kyma Kubernetes cluster, you have network traces. SAP Cloud Logging ingests all of this, correlates the data, and allows a developer to search through millions of log lines in milliseconds.
It's incredibly fast.
When a CPU spikes, you don't just see the spike. You can trace it down to the exact poorly optimized database query that caused it.
To really grasp the power of this, let's walk through a simulated incident.
Let's do it.
Let's say a critical microservice running on your BTP Cloud Foundry environment suddenly starts throwing HTTP 500 internal server errors.
Oh boy. Customers are getting error screens. The worst case scenario. The pager goes off at 3 a.m.
Right. But here, the automation chain kicks in immediately. First, a service called SAP Alert Notification detects the anomaly. It grabs this specific BTP event and routes it directly to the health monitoring dashboard in SAP Cloud ALM.
So the operator sitting in the command center, if they are awake, sees a red critical alert pop up on their screen.
Exactly. The operator clicks on the alert. From Cloud ALM, they are seamlessly navigated deep into SAP Cloud Logging, directly to the relevant time window.
Okay, so they don't have to hunt for the logs.
No hunting. Because it's OpenSearch, they quickly run a query against the traces and identify the root cause. Let's say the application's database connection pool have been exhausted because of the sudden massive spike in user traffic.
Okay, so the application is basically starving for database connections. Normally, in a traditional setup, this is where the operator frantically tries to log into a console, find the specific restart command, and manually reboot the service to flush the pool.
Which takes time.
It takes a lot of time, and humans make mistakes under pressure.
But in a mature DevOps environment, we automate the remediation.
How?
Cloud ALM can be configured to automatically trigger an operational flow via another service called SAP Automation Pilot.
I love Automation Pilot. It's essentially a serverless execution engine for your BTP resources.
It is. It executes predefined scripts or commands against your infrastructure. In our scenario, the moment Cloud ALM detects that specific connection pool error, it can trigger an automation pilot command to instantly restart the app.
Or dynamically scale up the connection limit, right?
Exactly. The issue is resolved in seconds, often before a human even has time to acknowledge the initial alert.
That is the holy grail of site reliability engineering right there.
Oh.
Alert notification catches the event. Cloud logging provides the root cause analysis, Cloud ALM orchestrates the response, and Automation Pilot executes the fix.
It's a beautiful chain of events.
It really is. But knowing the infrastructure engineers listening to this, I know they're screaming a specific word right now.
Oh, I bet I know what it is. Terraform.
Terraform, exactly. Automation Pilot is fantastic for operational remediation like restarting apps, but when it comes to provisioning the actual infrastructure from scratch.
Creating the sub-accounts, setting up the role collections, subscribing to the databases.
Right. The industry standard for that is Terraform, and the sources make a very explicit point to highlight the Terraform provider for SAP BTP.
It is a massive concession, and honestly a brilliant move by SAP to embrace the broader DevOps community here.
Right.
Terraform uses a declarative language. Instead of a human clicking through a web interface 50 times to set up an environment, which is painfully prone to error, you write a configuration file.
It just states what you want.
Exactly. It simply states, I want a BTP subaccount with these 3 services and these 5 user roles.
You run Terraform apply, and the Terraform provider reaches into the BTP API and builds it exactly as specified.
And if you tear it down and run it again tomorrow, it builds it identically.
This means you can version control your actual infrastructure, just like you version control your application code.
Infrastructure as code. It's essential.
The key insight here for the listener is that if your company is already heavily invested in Terraform for managing, say, AWS, Azure, or Google Cloud, you don't have to go learn some proprietary SAP tool to manage BTP infrastructure.
No, you just add the provider.
You manage BTP right alongside your other cloud providers using the exact same Terraform workflows you already know.
It all comes back to lowering the barrier to entry and integrating SAP into the wider technological ecosystem.
Okay. Take a deep breath.
Deep breath taken.
Everything we have discussed so far has been focused on the modern cloud-native side of things. We build our side-by-side extensions on BTP, we set up the CI/CD pipelines, we established the observability.
That all sounds great.
It does, but the reality is rotating banana still has that massive legacy on-premise SAP system running their core business. And we promised at the start of this deep dive to bring DevOps to the whole stack.
We did.
Which brings us to the most conceptually challenging part of this entire discussion. We have to tackle the Git-enabled change and transport system.
gCTS.
gCTS.
This is where we bring the speed of modern DevOps to the heavy freight train of ABAP environments.
Right.
And to really appreciate what gCTS does, you have to understand just how isolated ABAP development has been from the rest of the world for the last 30 years.
It really was its own universe. Like if you wrote a Java or Python application anywhere else, you used Git. You committed your code, you created feature branches, you resolved merge conflicts, standard stuff.
Very standard.
But if you were an ABAP developer, you wrote your code directly inside the SAP development system. It was locked in a proprietary database.
Right.
To move that code to testing or production, you relied entirely on the transport management system, or TMS. You created a transport request, physically locked the objects you were working on so no one else could touch them, and shipped it across the landscape.
And to be fair, it was incredibly robust.
Very safe.
But it was rigid. There was absolutely no concept of branching. There was no easy way for two developers to work on the exact same piece of code simultaneously without locking each other out.
Right, you'd get that error saying the object is locked by another user.
Exactly. You couldn't easily roll back to a previous version of a specific object either. Git simply didn't exist in the ABE paradigm.
Until now. The fundamental concept of gCTS is mind-bending for a traditional SAP developer. We are going to use an external Git repository like GitHub or GitLab as the version control system for our proprietary ABE code.
It sounds impossible, but they made it work. And to make that external connection work, gCTS relies on a few critical architectural entities that act as a bridge.
Okay, let's break down this bridge.
The first piece is the gCTS registry.
The registry. Think of the registry as the central directory or catalog, right?
Exactly. When you create a Git repository for your project on GitHub, the SAP system doesn't just automatically know it exists. The gCTS registry is where you explicitly link a specific external Git repository to a specific ABI package inside your SAP system.
Okay, so it establishes the mapping. It says, the code in this local ABI package belongs in the specific GitHub repo.
Precisely. That mapping is step one.
Okay, the mapping is established. Now, the old traditional TMS system still exists under the hood, right?
And it's still there.
And it expects to send code to another physical SAP system, like sending code from the DV system down the hall to the test system. How do we trick the old TMS into sending code out to the internet to GitHub instead?
That is the brilliant part, and it utilizes a concept called the VSID, or Virtual System ID.
Yes.
In a classic SAP landscape, every single physical system has a three-letter identifier, like DEV or PRD.
Right, the SID.
Because a Git repository isn't a physical SAP system, gCTS simply assigns it a Virtual System ID.
Oh. So the legacy TMS looks at the transport route and sees a target called, let's say, GIT.
Exactly. It thinks GIT is just another SAP server down the hall.
That is hilarious.
It works perfectly. When a developer releases a transport request, TMS routes it to the VSID. The gCTS framework intercepts it right there, translates the proprietary ABAP objects into flat files, and pushes them out to the external Git repository.
Wow.
It completely fools the legacy system into participating in a modern Git flow.
That is incredibly clever. It preserves the familiar transport request mechanism for the developer. They still hit release, but it changes the destination entirely.
Yes, and this leads to the concepts of commits, versions, and imports inside SAP.
Okay, those terms will be familiar to anyone who uses Git, but I imagine they have specific nuances in gCTS.
They do. A commit in gCTS is a snapshot. When that transport request hits the VSID, gCTS automatically creates a commit in the Git repository, representing the exact state of those ABAP objects at that moment.
Okay. And versions.
Versions are how gCTS tracks which specific commit is currently active in your local ABAP system.
Right, because unlike standard software where you just compile a binary from the Git repo, in SAP, the code actually has to live inside the database to run.
Right. The database is the runtime, which brings us to the import.
The import.
The import is the physical process of pulling a specific commit down from the Git repository, activating the objects, and deploying them into the target SAP system's database.
Okay, I have to push back on this for a minute.
Sure, go ahead.
Because it sounds like magic, but there has to be a catch. If gCTS is so brilliant, if it gives us all the power of branching and version control, can I just completely turn off my old classic CTS? Can I run my entire SAP system exclusively on Git from now on?
Absolutely not. And this is a massive constraint that you must internalize before you try to design your landscape. Classic CPS is still a non-negotiable requirement.
Wait, really? Why? If gCTS can translate ABP into Git, why can't it do it for everything in the system?
Because of the nature of the code. gCTS is designed specifically for your custom development. the custom ABAP code your team writes. But SAP systems require constant foundational maintenance.
Right. Patching.
You have to implement SAP notes, which are official bug fixes or security patches provided by SAP. You have to perform modification adjustment transports after installing a major support package.
Oh, I see.
Those core system updates fundamentally require the classic CTS mechanism.
Because they involve core system components that really shouldn't be subjected to the branching and merging chaos of a custom Git repository.
Precisely. gCTS does not and will not support the implementation of SAP notes. If you try to push an SAP note implementation into your Git repository, the system will actively reject it.
So the reality is a hybrid model.
Yes, hybrid.
Your organization's custom code flows through the modern, agile gCTS pipeline, utilizing Git. But your core SAP system updates, the foundational maintenance, flows through the rigid, highly controlled classic CTS pipeline. You literally have to maintain both tracks.
You are maintaining the high-speed rail and the freight track side by side, forever.
Wow. Okay, well, I promise this would be an actionable guide. We understand the architecture now. Let's talk about the actual implementation. You don't just flip a switch in SAP and turn on gCTS, do you?
I wish. No, the source material outlines a rigorous set of health checks you have to run first.
Right, the gCTS health checks, these are non-negotiable, aren't they?
Completely non-negotiable. If you try to bypass these checks, your integration will fail, and it will often fail in spectacular and really hard to diagnose ways.
Okay, so let's get into the weeds. How many checks are there?
There are 8 specific checks in total, and I find it helps to group them logically to understand why they matter.
Okay, let's group them by intent. The first group seems to be about basic authorization and system readiness. This covers the user permissions check and the system configurations check.
Right. gCTS operates under a specific technical user account in SAP. The user permissions check verifies that this user actually has the deep authorization objects required to interact with both the ABAP runtime and the underlying OS file system.
Oh, the OS file system. Why does it need that?
Because it has to physically write the Git files to a directory on the server before pushing them.
Got it. And the system configurations check.
That looks at the foundational SAP profile parameters to ensure the system is physically capable of supporting the gCTS framework. Things like memory allocation for the processes.
Okay, so the system is ready and we have permission. The next group is about the internal mechanics of the transport system itself. This involves the status of repositories check, the TMS configuration check, and the Git-enabled CTS internal check.
All right, as I mentioned, gCTS creates local repositories on the SAP application server's file system as a staging ground before pushing to the external Git server. The status check ensures those local directories actually exist and are writable by the system.
And the TMS configuration check.
That is vital because, as we discussed with the VSID, gCTS piggybacks on the legacy transport system. If your traditional TNS domain controller is misconfigured in any way, gCTS will just inherit those errors and fail.
Makes sense. And the internal check.
That's just a final validation that the gCTS software components are actually active and running in your ABAP system.
Okay, and the final group, which honestly seems like the most common point of failure, is the physical connection to the outside world. This includes the SAP kernel checks, the connectivity check, and the web services checks.
This is definitely where the rubber meets the road. gCTS requires a modern SAP kernel.
Why the kernel specifically?
Because it relies on specific executable programs at the operating system level to actually perform the Git commands. If your kernel is outdated, it literally lacks the vocabulary to speak Git.
Wow. Okay, update your kernel.
Yes. And then the connectivity check ensures your SAP server can reach out through your corporate firewalls and proxy servers to communicate with GitHub or GitLab over HTTPS.
Which network security teams always love.
Oh, they hate it. You have to open those ports. And finally, the web services checks ensure the OData services that power the gCTS Fiori user interface are active.
Okay. If any of those 8 checks throw a red flag, you have to stop what you're doing and fix the infrastructure. You cannot proceed.
Do not proceed until they are all green.
But let's assume everything is green. You are cleared for takeoff. The developer logs in and opens the gCTS Fiori application. This is their new workbench. But navigating this app requires a bit of a mental shift because it's divided into 2 very distinct views, the system view and the repository view.
Yeah, it helps to think of these views as representing 2 completely different roles in the company. The system view is for the administrator. It provides the macroscopic perspective.
Okay, so this is where you are configuring the global engine.
Exactly. In the system view, you manage the gCTS registry we talked about, you configure global parameters that apply to all repositories, and you manage team assignments.
So you aren't really looking at code here.
No, you are managing the platform itself.
But when a developer actually needs to work on a feature, they click into a specific project and they enter the repository view. This is the microscopic perspective.
Right. The repository view is the daily operational workspace. This is where the developer sees their commit history. It's where they create new branches for features.
And it's where they examine the actual ABAP objects tracked in the repository.
Yes. And crucially, this is where they access the conflict resolution editor.
Oh man, the conflict resolution editor. I want to emphasize this for anyone managing an ABAP team right now. Resolving a merge conflict is standard practice for a web developer, but it is a profoundly stressful, completely foreign concept for a legacy ABAP developer.
It really is. In the old system, objects were locked. Conflicts were physically prevented by the system. With Git, two developers can edit the exact same class at the same time.
And if they both push,
There is a conflict, and they have to resolve it manually.
So if you are setting this up, your immediate priority as a manager is training. You must have your developers practice using the conflict resolution editor inside the repository view on dummy code.
Absolutely.
Because you do not want a senior developer encountering their very first merge conflict during a high-stakes production deployment.
Training the team to navigate branching and conflicts in ABAP is honestly just as important as the technical configuration, maybe more.
Speaking of technical configuration, I want to dive into the absolute weeds here.
Let's do it.
The source material highlights several highly specific repository configuration parameters that act as the safety rails for this entire system. If you leave these as default, you are asking for trouble.
Total disaster.
So when an administrator goes into the configuration tab of a repository, what literal parameters do they need to aggressively manage?
Let's start with auditability and compliance. When a piece of ABAP code is translated and pushed to Git, you need absolute traceability. You need to know exactly which SAP user authorized the transport, and you need that reflected in the Git commit history.
Right, because if you don't configure this, what happens?
The Git commit might just say it was pushed by a generic, SAP system user.
Which will immediately fail an IT audit.
Instant failure.
So how do we enforce that traceability?
You set 4 specific parameters. You might want to write these down. They are client VC's commit message, client VC's commit description, client VC's commit as her mail, and client VC's commit as her name.
Okay, so what do those actually do behind the scenes?
They map the metadata from the SAP transport request directly into the Git commit payload.
Wait, so the SAP username literally becomes the Git author name?
Exactly. The SAP username becomes the Git author name. The SAP user's email becomes the Git author email. The transport request description becomes the commit message.
That is seamless.
It creates a perfectly defensible audit trail bridging the two systems.
That is critical. Okay, what about deployment safety? Because the nightmare scenario is an import failing halfway through, leaving the production SAP system in an inconsistent, broken state.
Yeah, partial deployments are terrifying. To manage that risk, you configure 2 parameters, VCC temporal error level and VC's error rollback.
Let's break those down. What does the error level 1 do?
VC's temporal error level defines your threshold for failure. In SAP, transport errors return a specific code. A return code 4 is a warning, an 8 is an error, a 12 is a critical failure.
Right, standard ABA return codes.
Exactly. You use this parameter to tell gCTS, hey, if the import hits an error level 8, I want you to consider the entire deployment a failure.
And if it fails?
That is where VC's error rollback comes in. If you set this to true, and the error threshold you just defined is breached, gCTS will attempt to automatically revert the SAP system to the exact state it was in before the import started, using the previous commit.
That is incredible.
It's an automated safety net to prevent half-deployed code from bringing down the core ERP system.
The final set of parameters deals with the sheer performance and behavior of the import process itself, right?
Parameters like VC's import type, VC object calculation, and VC's object index. These are highly advanced, but they essentially control how gCTS evaluates the code before importing it.
Why does it need to evaluate it?
Because by default, SAP might try to recalculate every single dependency of every single object being imported.
Which is safe.
It's safe, but it is incredibly slow. If you have a massive code base, that calculation could literally take hours.
Oh, wow.
By tweaking these parameters, an expert administrator can instruct gCTS to only calculate delta changes or to skip rebuilding certain indexes until after the import finishes.
So it's about speed.
Yes. It allows you to tune the engine for maximum deployment speed, but and this is a big but,
Mm.
you have to understand the dependencies of your specific code base to do it safely.
Okay, one final highly actionable insight from the sources regarding gCTS behavior. By default, gCTS tries to be helpful.
Too helpful sometimes.
Right. It runs automated background jobs to pull the latest changes from Git or to push automatically when a transport is released. But the sources explicitly warn that during complex branching scenarios, you need to turn this off.
It's absolutely true. If your team is managing a complex feature branch strategy with multiple developers working on parallel release tracks, an automatic background pull can cause absolute chaos.
Because it might pull down code you aren't ready for.
Exactly. It might pull experimental code into a stable test environment prematurely and overwrite what you were testing.
So you take the training wheels off.
You disable automatic pull and push.
Yeah.
It forces the lead developer or the release manager to take strict manual control over the pipeline.
They decide when things move.
Right. They decide exactly when a commit is pulled into the local system for testing and exactly when the finalized code is pushed back up to the remote repository. In complex architectures, manual control is far safer than blind automation.
Wow. We have covered an immense amount of ground today, and we have gone incredibly deep into the weeds.
We really did.
We started by unpacking SAP's mission to bring the CalmS framework to legacy operations without destroying them. We walked through the side-by-side extension model on BTP to keep the SAP S/4HANA core clean. We debated the merits of the SAP CI/CD service versus injecting Project Piper into an existing Jenkins setup. We definitively proved why Cloud Transport Management is the only logical choice over the dying CTS Plus system.
Rest in peace, CTS Plus Parade.
Right. We traced a simulated failure through Cloud ALM, OpenSearch-powered cloud logging, and Automation Pilot, while highlighting Terraform for infrastructure as code, and we just survived a comprehensive dissection of gCTS, from the VSID bridge to the 8 critical health checks and the exact parameters required for auditability and rollback safety.
It is a massive volume of information, I know, but it represents the undeniable future of enterprise IT.
It really does.
You cannot run a modern business at a slow legacy pace, but you also cannot afford to break your core financial and operational systems. These tools, BTP, Cloud Transport Management, gCTS, they are the literal mechanisms that allow you to balance velocity with stability.
Before we wrap up, I want to leave you, the listener, with a final architectural puzzle. A reality check based on the constraints we discussed earlier.
Okay, think about the daily reality of your development team. We established that gCTS is fantastic for custom code, but it absolutely cannot handle SAP Note implementations or support packages.
Right. Those core updates still mandate the classic, rigid transport management system, the hybrid model.
So the challenge here isn't just technical, it's deeply cultural. How will you train your ABAP developers to seamlessly context switch?
What do you mean by context switch?
Picture a developer's week. On Tuesday, they're working in the modern world. They are in the gCTS repository view, creating feature branches in Git, pushing commits, and navigating the conflict resolution editor for their custom code.
They are moving fast, acting like a modern cloud developer.
But then, Wednesday arrives. A critical security patch comes down from SAP.
Oh.
Suddenly, they have to abandon Git completely. They have to log back into the classic system, use the legacy transport request mechanism, and carefully apply the SAP node with no Git history, no branching, and no automated rollback.
It requires a completely dual mindset. They have to inhabit 2 different operational eras simultaneously.
Exactly. Mastering the commands, the parameters, the webhook configurations, that is only half the battle. Mastering that cultural context switch, ensuring the team knows exactly which pipeline to use and when, that is what will ultimately define a successful SAP DevOps transformation.
You are running a bullet train and a freight train on parallel tracks, and you are demanding that your engineers be master conductors of both. It's a monumental challenge, but with the specific configurations and architectures we've laid out today, it is entirely possible. But remember, the theory only matters if you put it into practice. Don't wait. Log into your BTP trial account, provision a sub-account, open up the gCTS Fiori app, and start experimenting with those parameters today. Thanks for joining us on this deep dive.